Okay guys, so I'm gonna prove the rest of the log laws. Okay, so the next rule is the exponent rule, which is log x to the n based a is equal to n log x based a. Okay, so why? The key is I can write x to the n as this. X times x times x times blah 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 times x and times. And I can use a multiplication rule for this. So what was a multiplication rule? It was xy base a equals to log x base a plus log y base a. The reason I have two terms here is because I have two terms here. So if I have, for example, 61 terms here, I would have 61 terms in the other side. So here I have n terms or n equal terms. So I can write n equal terms in the other side. So this would be log x base a plus log x base a plus blah 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 plus log x base a. They're all equal because you multiply the same thing by itself n times. And this is our thing, n times. So you have n of an equal thing. You have n of an apple. So you have n apple. So this would be log x base a n times. And this is n log x base a. Okay? The next rule, which is division rule, is very important too. Or call it law. Okay, so this law states log x over y base a is equal to log x base a minus log y base a. So why is that? So the key is I can write x over y as x to the y to the negative 1, right? So just replace x over y with this term, right? So write it as log x over y base a is equal to log x times y to the negative 1 base a. So here I can use the multiplication rule first. So I can write the log of the individual terms. So the first term is single x. So I'm going to write x base a. The next term is log y to the negative 1 base a. So in this case, for this part, the exponent law comes very important. The law that I just proved for you, this one. So you can see there is an exponent for an x, and you have the exponent behind the log, right? So here you have an exponent. So I can definitely write this as my coefficient of log, right? So this comes here as this one came here. Okay, so I can write it as log x over base a plus minus 1 times log y base a. And this is log x base a minus log y base a. Simple. Okay, so the next rule is base change rule. So base change rule or law. Okay, so this law is comes very important when you don't like whatever base you have in your equation or your expression. For example, you have an equation which one of its logs has something weird in its base. So you cannot play with the base oftenly or in 100% of situations. So you should change it. So you should change it completely. So this law will help you to change the base in whatever you want and you are pleased with. So this law states, oh my god, I'm stressed. Okay, so log x based a over log y over based to the same base as the numerator is equal to log x based y. Wow, this is stunning. Okay, so how to prove it? So you can see I have something with the base of something, but I changed the base to a. I can choose a, right? There's no limit for me to for choosing a. So a is independent from my question or the thing that I'm solving in an equation or whatever that is. Okay, so the proof. So like the method that we proved, the multiplication law, we name each of these to something. So log x based a would be w, log y based a would be z. So another way of reading a log is a to the w is x. Is it right? So a to the w is x. A to the z is y. Right? Okay, so here, can I say that a is equal to x to 1 over w? I can just say I rose both sides by 1 over w. Right? So here you can see the combination. Here you can see the thing that remains for the other side. Right? So I can write a is equal to x to the 1 over w. Same for this one. A is equal to y to 1 over z. Is it right? Okay, so you can see two terms are equal to y. So I think it's obvious that they are the same. So just write it as an equation. Okay? Rise both sides by w. So you get x to the 1 for one side and y to the w over z for another side. You ultimately get x equals to y to the w over z. Is it right? So take the log of both sides. So you're going to ask, log with what base? So here you should take the log with the base y. So why we want base y? Because I want to make the figure of log x based y, right? So this is my argument. I have no problem with it. I need the base y to make it look like this. So that's why I take the log based y of both sides. Okay, so log x based y is equal to what? Is equal to log y to the w over z based y. Log x based y is equal to w over z. And you almost proved it. W is what? Log x based a. And z is log y based a. Here you have it. Finished. This is one of the most important laws of logs. So for solving equations or application questions, sometimes you should change the base because some bases look very, very ugly and you don't want to deal with that. So you change it with this. You choose a base, which is a. You can choose it as 10, 11, 12, I don't know, 15, 200, whatever. And you can then solve your equation based on your chosen base. Okay, these are all the laws that you should learn and you should know for logarithm unit. I hope this was helpful and good luck with your studies. Thank you for watching it.